In the previous video, we were looking at the limit as theta goes to 0. What happens to the ratio sine theta upon theta? And we realized that it comes out to be 1. That is, sine theta actually comes out to be theta, equal to theta, right? Now, the next identity that we have been using quite frequently is the limit as theta goes to 0 of the ratio 1 minus cos theta upon theta. And we have used that this ratio equals to 0 as theta goes to 0. Now, how is that exactly happening? Let me geometrically show you what exactly we are talking about and what exactly is happening. So again, let us take a unit circle. So unit circle with the radius 1. Let me just draw OB at angle theta, OL as my base, and angle theta here, okay, angle theta. So angle BOL equals to theta. So that means that the arc length BL equals to theta, right? Now, let me again make a perpendicular from B to OL, which will cut OL at point A. So AB is the perpendicular, AB is the perpendicular, OA is the base, and OB is the hypotenuse. Now, base upon hypotenuse equals to cos theta, right? So base upon hypotenuse equals to cos theta. Now, hypotenuse is 1. What does that mean? That means this length OA is nothing but cos theta. The length OA is cos theta. But what are we actually interested in? We are interested in looking at 1 minus cos theta upon theta. So what exactly would be 1 minus cos theta? Now this length, as you see here, is cos theta. This is cos theta. And this length, complete length, if I extend OA to L, is actually 1 because the radius of this unit circle is 1. So OL is equal to 1 and OA equals to cos theta. So that means this small length AL, the difference between OA and OL will be 1 minus cos theta. So that's what is 1 minus cos theta. OL minus OA. OL minus OA is 1 minus cos theta, which is AL. So the length AL. So what we are interested in is saying that what happens as theta collapses to 0. So what I can do is I can extend it to another quadrant. I can extend this to another quadrant. Let me just do that. I have already given you the hint of the diagram. So here it is, okay. So this is just an extension of theta on the other side. So what we're trying to say is that what happens as theta goes to 0 from other sides, okay. What happens to the distance AL? Just logically think, when we are making theta go to 0, okay, logically this distance AL will disappear. Why? Because as previously for the sine, I told you that short arcs are almost straight. So that means that the arc BC will almost be the line BC, right? So that means the gap between the arc and the line will disappear, will be 0. So AL hence will be 0. So logically, as theta goes to 0, the arc BC will almost be equal to the line BC. Okay, and the gap AL disappears. And that is why we quote that as theta goes to 0, 1 minus cos theta, which is essentially the gap upon theta, equals to 0, because this gap AL disappears. And that's the reason why this identity exists.